All right, let's dive right in. Today, we're breaking down a real-world cybersecurity internship project, step by step. If you've ever been curious about what it's really like to hunt for and fix security holes on a corporate network, well, you're in exactly the right place. This quote, it's everything. It's the core of our entire mission. Because vulnerability management isn't just about clicking a button on some tool. It's a mindset. It's about learning to see your own network the way an attacker would. You have to think like the bad guy to build the best defense. So picture this. You're the new vulnerability management intern. And you've just been handed your first big assignment, codenamed Find and Fortify. Simple, right? Your job is to track down all the weaknesses across the company's digital landscape and then build a rock-solid plan to shore up the defenses. Now, here's what makes this so interesting and challenging. You're not just dealing with one type of system. Nope. You're diving into a hybrid environment. We're talking Windows servers, Linux machines, and even modern containerized apps. Your mission is to scan all of it, figure out what the biggest dangers are, and then create one single, unified plan to make everything more secure. But hold on, before you can find and fortify, you've got to know what you're even looking for. This is your intel gathering phase. You need to really understand your enemy, the vulnerabilities themselves, inside and out. So what is vulnerability scanning really? Well, think of it this way. It's about proactively checking for all the unlocked doors and open windows in your digital house before a burglar finds them. And every one of these known weaknesses has a unique name, a CVE, which stands for Common Vulnerabilities and Exposures. And you've got a couple of ways to look for those open doors. A network scan, that's like walking around the outside of the house, rattling doorknobs and checking the windows. But an authenticated scan, that's like having the master key. You get to go inside, check every room, look under the rugs, and really see if anything's out of place. You absolutely need both perspectives. Okay, so you run your scan, and it comes back with 100 different issues. 100! Where do you even start? You can't just guess. And that's where the Common Vulnerability Scoring System, or CVSS, comes into play. It's the industry standard for rating just how bad a vulnerability really is. And the CVSS score gives you this really clear breakdown. As you can see, scores go from 0 to 10. Anything that hits a 9.0 or higher is labeled critical. That's your 5-alarm fire. This system is what lets you immediately cut through the noise and figure out where to focus first. Now, imagine your scanner spits this number back at you, 9.8. Whoa, that's not just a high score, that is a catastrophic, cancel your weekend plans kind of score. This is the kind of number you'd see for a major flaw, maybe something in a core library like OpenSSL that could let an attacker just walk in and take over a server completely. And a score like 9.8 triggers an immediate, non-negotiable response. This isn't a let's get to it next week situation. This is an all hands on deck, drop everything else emergency. The standard for a critical flaw like this is to have a fix deployed within 24 hours. The clock is officially ticking. All right. Theory's over. Now it's time to get your hands dirty. Your entire internship project is broken down into 4 distinct trials. Think of them like levels in a game, where each one builds on the last and gets you one step closer to your final goal. And here's your roadmap. It's a clear 4-step process. First, you scan to find the problems. Second, you prioritize them based on risk. Third, you plan out how you're going to fix everything. And finally, you visualize your findings so you can report back. Simple, logical, and super effective. So your first task is to create a vulnerability summary table. This is your master list of all the problems you found. For every system, you're going to log the specific CVE, its severity, and the best way to fix it. And notice the different fixes. A Windows server might just need a specific patch, but a container, that might require swapping out the entire base image. Next up, prioritization. And this is so important. A vulnerability's severity score is only half the picture. The other half is how important the system is. A critical flaw on your main production server is a DEFCON 1 situation, but that same flaw on a temporary test machine? Still serious for sure, but the urgency is different. This matrix is how you make those smart, logical calls. Okay, so we've been putting out fires. Now it's time to fire-proof the building. The hardening plan is where you shift from being reactive to being proactive. And you're not just making stuff up. You're using industry-standard best practices, like the CIS benchmarks, to build a secure foundation for every single platform. Your final trial is all about one thing: communication. Because let's be honest, handing a manager a giant spreadsheet full of CVEs is Not effective. But a heat map? That tells a story instantly. It visually screams, hey, these systems over here are on fire. It makes getting buy-in for your fixes so much easier. You've made it through all 4 trials. Now you're ready to assemble your final deliverable. And this isn't just a jumble of tables and charts. It's a complete, professional hardening blueprint that shows your entire journey from discovery all the way to defense. This cross-platform hardening blueprint is the whole shebang. It's got your summary table, your prioritization matrix, the hardening plan, and that awesome visual heat map. And you cap it all off with a quick presentation to summarize your findings for the higher-ups. This is what a real-world security assessment looks like. So how do you know if you nailed a project like this? Well, just look at how it's graded. The heavy technical work, the analysis, prioritizing, and strategy, that's the bulk of it. But look, visualization and documentation are a huge chunk too. It's not enough to just find the problems. You have to be able to communicate them clearly and professionally. You know, finishing a project like this isn't just about checking a box for your internship. The real prize here is the transformation. You've gone from just knowing the theory to actually doing the work, and in the process, you've leveled up your skills in a massive way. Seriously, consider this your achievement badge. You've just gained real, tangible, resume-worthy skills. We're talking vulnerability scanning, system hardening, container security, risk assessment. These aren't just buzzwords. They're the building blocks of a career in cybersecurity. And they even touch on DevSecOps, which is all about baking security in from the start. So why does all this matter? Because when you finish a project like this, you're not just a student anymore. You have practical, hands-on experience that makes you a prime candidate for some really in-demand jobs, like vulnerability analyst, DevSecOps engineer, or security compliance specialist. And that brings us to our final thought. You've just mastered the art of the periodic scan and hardening project, which is fantastic. But in a world where new code is being shipped every single minute, is doing this kind of scan once a quarter enough? It's a question that pushes us toward the future, toward continuous monitoring and automated security, something to chew on as you continue your journey.